All right, awesome. So I have so much content. I want to get started right away because it's my first time ever doing this talk, and it's so much goodies. I was actually really excited. I knew it was going to be a good session when I got excited putting together a slide deck and all these demos, and like things actually worked, and I was like, this is going to be awesome. So how many of you today are developing with Xamarin in general at all? Mobile apps. Cool. A few of you newer. How many of you, with your hands raised, are doing Xamarin native development? So like iOS storyboards, Android XML, a few of you, and Xamarin Forms? Cool. It's going to be a little bit for everyone. I'm going to focus on Xamarin Forms, but I'm also going to talk about some futures and some really exciting technology that's coming down the line for this fall. So a lot of what you're going to see today is available today, whether it's in stable today, in a pre-release NuGet, and then some of the stuff at the end I'm going to talk about, which will be coming out this fall, and I'm so excited about it. I put all the code, all the slides, they're all in that link. I was like, I'm going to put it right in the beginning this time instead of at the end. And if you're at my talk earlier today, it's also on that slide share and on my GitHub as well. And I put links to everything already, so you'll have everything you need. So I'm James Montemagno. I'm a principal program manager here. When someone was taking a picture, you can take a picture. Anyone else pictures? Pictures. Go, take the pictures. There you go. It's just my name, too. That's the easiest part. All right, a few more. And good, too late. I'm James Montemagno. I'm a principal program manager at Microsoft. I worked at Xamarin before that for nearly 3.5 years. And before that, I was actually a customer of Xamarin for 2 years at a small startup building all of their mobile applications for iOS, Android, and Windows. I joined Xamarin 4 years ago just because I love the technology. I love the ability to create great native applications in the tools that I loved and the best programming language ever created, C#. I live in this bright, sunshiny city of Seattle, Washington, where it's exactly like it is outside today all the time, where I drink all of our coffee, which I've had about 4 or 5 cups here in Oslo today, and I build great mobile apps. This is what I love doing. I love my city, I love coffee, and I love apps, and often I'm talking about all of them at the same time. So we're going to have some bunch of cool demos today, a bunch of different applications. If you have any questions at all at any time, feel free to reach out at me. That's my direct email. It goes right into my inbox, I swear. It's right there. That's my blog, and that's me on Twitter and GitHub. So if you have any questions, just Google my name, and these are all on that slide, like I said earlier. If you want to hear more from me after NDC, and I travel all the way back through Reykjavik, all the way back to Seattle, you can listen to me every single week on a podcast I do called Merge Conflict, which is super cool. And I also have a show on Channel 9 called The Xamarin Show. That one I came up with myself because I'm real original with titles. It's a show about Xamarin. It's actually really cool. We have people in the community come on, talk about stuff that they're building, and a bunch of new stuff internally that we're working on. So be sure to check out that stuff. I also have a bunch of stickers and stuff down here. Please take those at the end. You don't come up right now, but at the end. Cool. So if you're brand new to Xamarin, which a few of you are, we have this great approach that we call Xamarin and Xamarin Native, which enables developers to build out a shared C# business logic base for all their applications. So your models, view models, RESTful service calls, SQL integrations, Azure integrations, things are the same that are just .NET code. Because we have a .NET runtime that runs super fast on iOS, Android, Mac, and of course, Windows. So traditionally, you build out separate user interfaces with iOS storyboards, Android XML, and Windows XAML. And this is what I fell in love with 6 years ago when I started with Xamarin. And if you're looking for super optimized, like sub 2 second start time and access to every single control and everything like that, this is amazing, and that's where you want to be. So there's tons of applications today that are building out these native user interfaces using that shared logic, which is around, usually on average, 70% of all code in the application. But developers kept asking us over and over again for some way to share even more code, or perhaps write the user interface just once, but not lose that Xamarin native goodness. And that's what Xamarin Forms comes in. It enables you to build a shared logic base, but also a shared UI code base on top of it. And what we did is we abstracted things that were common across iOS, Android, and Windows into a common XAML markup. So you have a button, and while it's a button in the XAML, when it actually gets rendered on the page, it's still a native UI button, Android widget button, or a button over on Windows. So you're still getting access to that native capability. But it is a framework, so there's obviously a little bit of overhead that you're going to have there, and also some implications that you're on this layer on top of a native layer. But we didn't want to lose that native goodness. That's why I kind of fell in love with Xamarin Forms, because I was a XAML developer myself. So data binding and navigation all came natural to me. What's cool here is that no matter how you're building with Xamarin, that's my Xamarin 101 really quick, is that everything's included and everything's open source, including Xamarin Forms. When Microsoft acquired Xamarin, we made everything free, included in your Visual Studio subscription, and we open source everything under MIT. So you'll even see some statistics today about the contributions that have been made to Xamarin Forms from the community. So what's great there is that if you want to change some stuff in Xamarin Forms, you don't want to wait around for us, you can just simply pull down the source code, build it yourself, and have your own custom build of Xamarin Forms. And there's tons of companies that are taking advantage of that today because they want to do some crazy custom stuff that we're probably never going to pull into Xamarin Forms. So you can build everything in Visual Studio. I'm gonna, either for PC or Mac. I'm going to be doing everything kind of in both. So we have some demos in both today. And Xamarin Forms, my brief 101 overview for anyone that's coming in, is I talked about that shared code layer of when you might want to do the traditional or Xamarin Forms. And what you can notice here is that that shared C# logic is still the same. So my models, view models, RESTful service calls are the same. It's just how much of Xamarin Forms you want to opt in for. So there's a whole bunch of goodies that we're going to talk about today. There's pages, layouts, navigation, data binding, animation, a bunch of services built into it. There's tons of pages and layouts, so you can decide between master detail, navigation, tab controller, and different ways of laying out your controls. And then, of course, there's great controls. And what we're going to talk about today is not a 101 session. This is the 5 minutes of 101 of Xamarin. We're going to go straight into the deeper dive of what Xamarin Forms is capable of and some of the new technology that's in there. Now, this is the stuff that's in the box, but you can always leverage and create your own. And we have a great ecosystem of different partners such as Syncfusion, DevExpress, and Telerik that are creating great controls for your applications. So at a high level, if we were looking at a Xamarin Forms application, there would be a bunch of XAML for like a login page where I have a stack layout, 2 entries, and a button. And while it's all XAML, it's just against the Xamarin Forms schema. So the XAML looks the same because it is XAML, but some of the controls and properties are different. So what we're seeing is that we're inside of a tab page. So I get iOS tabs with icons on the bottom, Android with material design, and a Windows 10 application. So the application that I'm going to be optimizing and extending today is this weather application. I use it all the time. And I love it because it's simple, but we can make it real complex real fast. So this is the same application running on all 3 platforms. And I'm going to talk about the shared code, and then we're going to optimize it. So it's inside of tabs. So here I've already searched for Oslo. So I have my weather that's coming in. Here, I'm tethered against my phone, so we'll see how this all works. I have the forecast here. And if I come in to my iOS simulator and type in Oslo, Norway, and we'll use metric for everyone, say get weather. This should go out, grab our weather, and it's 13.83. I can get my forecast here, and I can see all the forecast that's coming in, very similar to Seattle. Actually, we can see. $12. And rain, very similar. So there you go. We're the same. So this application was all built in Xamarin Forms. I'm going to talk about the structure here. So what I have is something very similar to any Xamarin application. Here I'm using a shared project. You could be using a PCL or a .NET Standard library. I'm a big fan of shared projects. So this is all my shared code. So I have cells, controls, helpers, interfaces, services, views, and view models, and my full app. And it's not too complex. I just have I have this weather service here that's going to go out, and I use this Open Weather Map API to go grab some JSON, deserialize it into this weather route, and then pull it in, whether it's the city or GPS that I'm pulling in. I also have a view model here that's going to go out and has this weather service and some data binding for location to use GPS if I'm imperial or not. I'm using some plugins so I can automatically save the imperial settings, the temperature, things like that. And then I go out and I decide if I want to use GPS and actually use another plugin for Xamarin to get the geolocation, or just enter the location here, and then I use some C# stuff to format up the text. Now, everything that's happening here is I just have it basically in a tabbed page where I'm creating my new weather view model in 2 views. Nothing crazy. And I have my weather view here. My weather view, I'm just stacking everything. I'm a big fan of stack layouts and putting stuff together. I have an entry here, and what's kind of unique about that is as I toggle, oops, not that one, the use GPS, this enables and disables automatically. And what I'm using is a newer feature called triggers. So what I'm saying is, for this entry box, listen to this trigger. And when this trigger happens, do something to a property. So what I'm saying here is whenever this data trigger happens, which is a binding to the use GPS, whenever that changes back and forth, set the enable to false. So when this is true, set this to false, and then it will automatically do the reverse. So I don't have to set up additional data bindings or anything like that. I can just actually put that into my code, which is kind of cool. I have a few other stack layouts in here, such as a label and a switch. I have some buttons in here, and I have a stack layout that's going to put some padding around this activity indicator for me. That's my base, and I also have a forecast view here, which is going to be a list view of different items. I have a little bit of platform customization built right into the XAML to do on platform. So on iOS, the separator color is transparent. And then I just have a view cell where I'm stacking up an image, a stack layout, and a few labels in there. So that's the base of what we're working on today. So let's talk about some stuff that's built into Xamarin Forms that's awesome, that you may be using or may not be using today. And there's a lot built in there. And the first thing is compile time XAML. All the XAML traditionally had to be parsed and inflated at runtime. This was how Xamarin Forms was first kind of created. In fact, when it was first created many moons ago, XAML didn't even exist, but everyone wanted XAML, so we added XAML. So what happened here is that we wanted to actually make XAML faster because parsing it and inflating it at runtime is slow. And also, that means it also has to bundle in your entire XAML into your application. So we added this thing called compiled XAML, or XAML-C, you'll often hear it, which parses it and turns it into an intermediate language, into IL, that can automatically be booted up super fast in the runtime. This can be turned on at an assembly level. Here, we can say XAML compilation compile, and that will do it for our entire assembly, so anything that's in there. So you could have multiple assemblies, and you can choose that on each assembly. This is an opt-in compilation flag. I've been using it since it came out, and I've had no issues, really. It's come along quite a long ways. But you can also do it at a class level. So that means if you have a single page that maybe is crazy complex and you're using tons of custom controls and all this other stuff, you may want to skip it. So if you skip it, then at compile time, that XAML will still be put in to your application. Adding compile time XAML does a few things for you, which I'll kind of highlight. It does some error checking at build. It'll obviously reduce your app size because your XAML is compiled and your app is faster in general, just by one single flag. There's a bunch of other stuff built in. A lot of people always want to use these crazy IOC containers and dependency service and add all these crazy NuGets. You don't have to because it's built into Xamarin Forms. We have a dependency service that's super optimized, and Xamarin Forms uses it itself. It's really nice. So essentially, when you want to reach down into native functionality for iOS, Android, or Windows, you can simply use the built-in dependency service. And I'm going to demo a bunch of these features in a row. We also have a messaging center to do pub/sub. So here, for instance, you could send messages across the wire from one page to another page or from one view model to another view model. This will allow you to essentially loosely couple your pages or your data, or maybe have your actual iOS core application talk to your Xamarin Forms page and cross-communication. And this is built right into the box, so there's nothing else that you need to do, and it's optimized for Xamarin Forms. So here, for instance, I can subscribe to messages, which is based on a string, so this add new. And whenever that happens, I just give it a function that will be executed. So on the details page, I will send a message with an expense, and then that will get triggered back into my master page so I can add it into my expense list. When you have really complex parts of data, we have these things called data templates. So in this example of these monkeys that are chatting, normally you would have these this list view with all these different cells, and you might try to shove a bunch of logic in there. So, well, if it's the receiver, then make it blue and data bind to this color and then shift it to the right or hide things and collapse things. So data templates allow you to optimize your list view and have multiple cell types built in that are super optimized. And I'm going to demo all this. Additionally, I talked a little bit about this earlier, is the platform customization. So being able to come in and for any property, say if you're on iOS, Android, or Windows, to automatically set different properties. And additionally, you can do this on phone or tablet or desktop. You can say on idiom. So on idiom gives you the different aspects. So let me show you a bunch of these different features. I'm going to point out a few things as we go through some code. So the first thing I'm going to do is talk about how to actually improve this. So the first thing here is the main application. How can we improve it? So if you have a legacy Xamarin Forms application, you may not have upgraded to the latest app compat. So this is on by default now, but we can see I get material design, material theming. And I get that because I went into my Android application and I inherited from Xamarin Forms app compat activity. So there's kind of two flavors of Android with Xamarin Forms. There's a Forms activity and a Forms app compat activity. There's a few resources and styles that you set up, but that will essentially enable you to get this actually super nice app compat, and it's all fragment based. So actually just turning that on in your application makes it a lot faster. So that's one thing I didn't kind of highlight in slides, but is there. What I can do up here actually is we can notice that I have this assembly export of compile. So that's that XAML compilation. So if I actually just say skip on here, so one flag. I have this in my shared project, so it's in everything. But what's nice here is if I come into this application and for some reason in my weather view, I was going to drag it over here, I spelled padding wrong. And if I come into my, let's say, iOS application and I build it again, I've spelled padding wrong, but when I build it, no XAML compilation or anything is going to happen on this actual application. So when it builds and compiles, it's going to tell me that everything is totally fine and working just great. The problem there is that when I run my application, since there's a typo in my XAML, it's going to crash because it won't be able to find this padding. So by turning on the XAML compilation flag, which here I can actually come in and do it on just the single page. So if I put it above this class instead of assembly, I can say XAML compilation here. Bring in the Xamarin Forms XAML namespace, and I'll say .compile. Now, when I come in and I compile this up, just for that view, we should see that I should get some new errors. Let me go ahead and pin this down. There we go, right there. So it'll say no property binding of padding was found at all. And I've been able to turn this on and essentially find all my crazy typos that are going on. And as soon as I fix that, boom, it'll be good to go. Of course, you probably want to turn on at the assembly level, see how everything's performing, and then kind of go from there. So that'll build up, everything's successful, and the error goes away. So let's go ahead back into here, and we'll go ahead and turn on the whole application so it's nice and fast. There we go, and compile. Cool. So other little tiny things. So some parts of this code that I've optimized are actually the list view. So inside the list view, there's this hidden flag called caching strategy. Caching strategy was added quite a long time ago, but it's not on by default. So how would anyone know about it? And that's a great question. So a lot of these things, eventually we're going to make just on by default, but a lot of things are still opt-in. So caching strategy has two different types of properties that you can set. One is retain element, which is the default. And this essentially will create a new cell every single time as you scroll. So if you're like, dang it, all my list views are a little bit slow and laggy, why is that? Well, it's because retain element is on. When you go ahead and toggle it to recycle element, this will cache all of your cells. So it'll measure the screen and say, oh, there's 10 cells. So it caches 10 cells, and it'll automatically recycle all the data bindings and that cell for you. With the Xamarin Evolve conference application that I built that's open source, by turning on this one flag, For all my beta testers, I did a trial and error, because I was like, how big of a difference does it make? So I turned it off by default. And the first thing that our MVPs told me were that, this one list, when I go like this really fast, it's a little bit slow. And I go, well, no one's going to use it like this. And they're like, well, we're going to use it like that because we're going to see how good of an app you made. And I said, OK. So I turned it on, and everything was super butter smooth. So just that one flag is super powerful when you're actually using your list views to optimize them. I talked a little bit about data template selectors. So here, for instance, this list view just has a item template built in. So what I've done is I said, well, wouldn't it be cool if it's raining, maybe I'll make the black background blue, and I'll put it on the right-hand side, and I'll change some of the different colors and properties. What I normally have to do is shove tons of stuff in that view cell and say, is it raining? And then show this thing. Is it not raining? Hide this thing, and do value converters and all this stuff. So what I did is kind of like that monkey chat application is I created two cells. I took the exact same XAML and I put it into a view cell. So it's kind of highly reusable, and I put it into a grid. So there's grid, column definitions, and I have the same things here for the display temperature and the display date. And I created another one called my rain data template. So here I have a different background color for it. I have a display icon, and I set different text colors and properties for this actual view cell. To set up the data template selector, it's crazy super simple. So what I do is I create a little class, this weather template selector, and I inherit from data template selector. Inside of here, I create two private read-only data templates, which will be initiated for the first time right here. I say create a new data template of this type, and this template type knows that it's a cell. So when I go to definition, it knows that it's a view cell. And then there's one method that you override, which is the onSelected template. So as it's scrolling through your list, it will automatically call this method. It'll pass you the object that is being data bound. And all I do inside of here is I say, if it's rainy, return the rain data template selector. If not, return normal. So now back inside of the XAML, here what I can do is I can actually delete this entire item template here. I'm going to go up into this content page. I'm going to add a few attributes up here. The first thing is I'm going to need to get access to it. So my namespace is myweather.cell. It's in the myweather assembly. Here I'm going to add a content page resource here. So this essentially says, for this page, I'm going to use a data template called weather template selector, and I'm going to give it a key of weather template selector. So what's unique here is that I'm doing it at the page level. Yes, I could expose it in my app XAML, and I could expose everything in my app XAML, but then you're going to have a slow startup time because now you're having this huge app XAML that gets loaded. So only load resources when you need to. So now what I can do is on the actual list view, I'm going to add an item template and set it to a static resource of the weather template selector. So now when I rerun this application with just those few modifications, I have the compile time XAML on. I'm now using this new weather template selector that's built in on top of here. And we're going to build it up and redeploy it onto any of the three different platforms. So here I'll just redeploy it on iOS here. Give it a second to launch. Bup. So I'll say get weather. So now when I go over to my forecast view, now we can see that I actually have the different templates that are being selected automatically right here. And if I come into my selector, and I actually put a breakpoint here, I can actually go down and start scrolling a little bit on this page, and I automatically hit that breakpoint where I can then inspect the actual weather route that's coming in. So you can still debug this, all that data binding is happening. And I'm caching all these cells automatically in that data template selector. It's obviously a little slow because I'm tethering via my phone here, so it's a little bit strange. Normally not my at-home setup, but it's what was working this morning. So I can actually see these different bindings coming in place, which is really cool. And I just have to change a few lines of code to optimize it. But what's nice here as an added bonus is that I've now broken these templates out of that XAML, right? So I could then reuse them elsewhere into my application, kind of reducing my app size. So now they're highly reusable view cells. And I find that if you look at some of the apps that I've built, I have a lot of view cells that I'm just reusing in different pages. All right, let's talk about a few other XAML optimizations. And the first thing I'm going to do here is come into the XAML, and I mentioned I have a lot of stack layouts. But all these stack layouts are actually causing performance issues on startup of this application. Because what has to happen is I have to create a full layout, add this, create another layout that's inside of it, put down multiple views, another layout, and I'm stacking up layouts inside of layouts inside of layouts. In fact, you can see inside of here, I'm only using a layout to add padding around that actual thing. So the first thing that we want to do is, this is silly. That's terrible. I know I have old code littered everywhere because we didn't have one property called margin. And now we have margin, and now you can add margin to any single control. So if you have a Xamarin Forms application where you have padding for no good reason, because we all do, it's okay. Start adding margin, and that's all you need to do. It'll totally fix it. But it's still not good enough because I'm using these stack layouts, which we all want to use because they're super easy, but what I really should be using is a grid. So I actually have the grid code here. I'm going to talk about why this is way better here. So I'm going to go ahead and copy this code up and delete everything, boom, and do it here. So the grid in Xamarin Forms is super optimized because it's a single layout that I can then host multiple layouts inside of. By default, everything can be set to auto heights, so it'll automatically configure it for me, or of course, auto expanding heights here. What's unique is that it's still all of the same elements and controls that I had earlier, but I can now specify what grid row, grid columns, grid span if I want to go across. And you can say, well, James, I see that you're doing something dirty because you have a stack layout inside of this other one, and you just had one before. And yeah, if I wanted to further optimize it even more, then I would add additional rows and make these all auto inside of here. But I wanted to group these all together. But even putting inside this one grid, I've removed about 3 or 4 different layouts of this application. So if you're not using a grid, be aware of trying to look at that first to actually start optimizing your application. So recycle element, caching strategies, XAML compilation, app compat, using a grid, using margins. And here you can use the same margin and thickness, everything here. Boom, good, 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 good. What else did I talk about on there? Dependency service. The dependency service allows you to reach down into the platform-specific code for iOS, Android, or Windows. So you don't need your own dependency service or any IOC container. Everything is built into Xamarin Forms. And everything is based on interfaces, so everything is super nifty. So let's say I wanted to create some toast and a little pop-up that maybe doesn't interact with the user interface. So here I'm going to specify an iToast. And inside of here, I have a simple method in my interface that's called makeToast. So I'm just going to do this on one of the platforms. You could do it on one or all of them. I'm going to go ahead and do this on Android because I know there's a toaster inside of it. So I'm going to go into my helpers, and I have a toaster here. I think it's funny that I called it a toaster. And I implement the one method called makeToast. So what I can do at this point is I can come in, and I can say var, I'll grab the context, and I'll say forms.context. It always has access to the current context since I'm inside the Android application. And I can actually cast that as an activity because it's always an activity. There we go. And what I can do now is I could simply say context.make, or is it toast? What am I doing wrong? As activity, context, activity. I'm silly. Toast dot. Sometimes you do Xamarin Forms for so long, you forget how to do anything. So make text, there we go. And I'm going to pass in my context, which I guess didn't even need to be Mactivity, so we don't have to cast it. That's good. Save some stuff there. And then what I can do is simply pass in my message. And then what I'll do is I'll say toast length dot short. Now what I can do at this point is I've implemented this single method here. And I can come up and use this assembly export and say dependency. And this dependency, I'm going to go ahead and zoom in for everyone because I like zooming. This dependency here is a Xamarin Forms dependency, and it takes a type. So I'm not really necessarily registering a interface, but I'm doing type of toaster here of my class. And what this will do is at startup, when it registers all the dependencies, it'll see all of the interfaces that I implement. And then I can go and grab it. Now, if you don't want to use this assembly export because you're like, James, I don't like that, what you could actually do is come into your main activity here, and you can say Dependency Service dot register. And then you can pass in different properties here of the specific type and implementation. So here, if you want to be very verbose, you can say the type here would be I toast and then toaster, for instance. And we can bring in those specific namespaces, my interfaces, and there we go. So if you're more in the vein of only registering certain dependencies, you could do this as well, where I'm explicitly doing it for the interface. I'm going to go ahead and leave it on the assembly because I just do it because I think it's really easy and super simple to use that export. And then when I want to use it, here I can simply come into this weather view and we'll just say, I don't know, something silly like on appearing. And what I can now at this point say is, do I have a toaster? So toaster, and I'll say dependency service dot get, and I'll give it the interface of I toast, there. Now what's unique about this is I'll go ahead and bring in this namespace, is it asks us for this dependency fetch, and by default it's global, so it'll only create one ever. You can also set it up to do a new instance every single time you call it, but we'll leave it in with the global instance because I only want one toaster any time. So since I've only implemented on one, what I'll do is I'll just say toaster dot, and I'll say make toast, and I'll say hello Oslo. Here we go. Cool. So now I'm reaching in and I'm accessing some Xamarin or some Android-specific capabilities of this application without having to do really any work at all. I just specify my interface, which is now going to be testable. I can make sure that this is registered with my dependency service, and then I can go ahead and redeploy it over here on my Android device. So give it a second to recompile and redeploy. There we go. And ideally, what did I do wrong? Toaster. Oh, I know what I did wrong. I didn't actually show it. Smart. Dot. I'm glad that no one told me. Appreciate that. Dot show. And now we can rerun it. It's like, Android. There we go. Just to prove that it works. There we go. So that should totally work. And I don't know why I have a breakpoint up here because now it's going to go away. There it is. Perfect. Now it's totally there. Awesome. So I'm reaching in, getting some native functionality without doing a lot of work, and that's what's super important. So that's just stuff that's kind of been baked in for a little bit, but then you're probably saying, well, James, I've kind of optimized it a little bit. I'm learning about the optimizations, but how do I take it a step further? What else can I do when I really need to spice up my application? So we've covered a lot of those slides and those main things that I showed, but I want to take it a step further. I'm going to talk a little bit about custom renderers. If you've done any Xamarin Forms work, you've probably done a lot of custom renderers, and you've probably done way too many because you shouldn't be using a lot of custom renderers. You should use only them when you need to. Custom renderers are awesome, though, because they allow you to overwrite the base functionality of any Xamarin Forms control or implement any of your own custom controls in your application. Because if you think how Xamarin Forms works, even today, is it has a button, and every single view has its own renderer. So you can create your own My Button and then completely override it on Android, iOS, or Android. This is pretty cool. However, what I often find people doing is creating a custom renderer to change one or two properties. If you're doing that, you're doing it wrong, because what I'm going to talk about next, after I talk about custom renderers, is what you want to do. So this is only when it's something crazy out of the box that you really need to optimize for. Some good examples are a full custom page. Maybe it's like a page from my iOS application that I want to pull in. Maybe it's like something crazy where I'm taking a circle and cutting it out, or I'm adding a full calendar, some control that doesn't exist. Or in this instance, maybe I want to add ads to this application. This is the perfect use case for a custom renderer. Think of an ad. It could be a Google AdMob ad. It could be an Apple ad. It could be some other Microsoft ad. This is something that's never going to exist in Xamarin Forms, because who knows what type of ad you want to use. So to create an ad inside of this application in a custom renderer, it's really quite simple. What I'm going to do first to implement a custom renderer, because it's a full control, is inside my Xamarin Forms application, I have an add control view. And here, there's literally no code inside of it. It just says, hey, I am a Xamarin Forms view, which means that I'll inherit from all of the Xamarin Forms properties, so background color, all that different stuff that's in there. Margin, padding, I get access to all that. I'm just a view. So this is what I'll actually be accessing inside of my XAML. Now, some other things that you may put on top of here are additional properties and getters and setters that you may want to listen for. So for instance, if this ad had an ID or you wanted different refresh rates, you can add additional bindable properties right inside of here. But for this ad view, I'm not going to do anything. I'm going to have this ad view over on Android first, and that's what we're going to take a look at. So I create this Android control view renderer, and this is how it's implemented. The first thing that we're going to see is that I inherit, and I bring in a few things first, is I'm using Google Play's ads inside of Google Play services, so AdMob integration there. And that's the only using statement that I brought in there into the actual Android application. So what this is telling Xamarin Forms is that I'm a view renderer, and I am going to be of type add view control, which is my custom control, and the actual native widget is an ad from Google. And that's how it's going to know to actually inflate the base control. So I have a few properties in here. I have an ad size, which is coming from that Google AdMob integration, the ad view. I have a method that I created by myself that's going to return this ad view. So I only create it once. I have the ad unit ID, so I set up all my AdMob and Firebase stuff behind the scenes earlier this week. I go and create a new ad view. I set the size. I set the ID. I create some params, so it automatically inflates it. I say, load the ad, and done. The only thing that I really need to implement inside of this is one override that says on element changed. So I have access to the control. So if the control hasn't been created yet, I say, hey, go create that ad, and then I'm going to set the native control. Set native control is strongly typed because I told it that it is of type ad view. So it's going to actually pass it down. So literally, in less than 50 lines of code, I've brought in my ad into this application. So now if I come back into my weather view, up top here, I've added this controls. So I add all my custom controls there, and I add a new XML namespace. I come down to the bottom, and I'm going to say add control. Our XAML IntelliSense, surprisingly, is smart enough to know that it's actually in that namespace, and it lays down all that stuff for me. I don't have anything else installed. If I want to, I could set like background colors, or I could say it's red. I could say grid.row equals 4 and grid.column span equals 2, so it spans across. Boom. Now I have access to that full control, and I can go ahead and deploy yet again onto this application. And what we'll see on the bottom, is since it's in an emulator, is a test ad coming from Google. Boom. So there's the background color. I think I have to do one more thing, because this worked earlier. What did I do? -10. I think I have to do that, just to kind of get rid of any of the spacing that's in there. That should work. 4, this, yes. 4, that's good. There it is, perfect. Now we have our ad. So now our ad popped up, it's there. I think probably if I waited long enough earlier, it would have showed up too, but I don't like to wait, seeing it probably is going through my HSPA+. So cool, so now I have this ad, I have this custom renderer built inside of it, and that's a great use case when you actually need to have some control that doesn't exist in Xamarin Forms into your application. But I said, you're probably using custom renderers wrong, and you probably have way too many of them. What often developers want to do is get access to a few properties in a Xamarin Forms control that isn't exposed, because everything in Xamarin Forms is an abstraction. So what we want to do is use effects. Effects are the most powerful thing. I'm going to say that like 1,000 times because everything's the most powerful thing. It's one of the most powerful and easy things to implement in your application. So effects are like a custom renderer, but super light. They allow you to extend any control and change properties of any native control. There's no methods or events to implement or override or anything like that, really. Everything is optional. So you can implement it on one platform, 2 platforms, all the platforms, and they're all stringly typed, to which I'll talk about here in a second. And there's only 2 methods that an effect cares about: the onAttached and onDetached. So onAttached says, hey, this is about to show up. What do you want to do? And onDetached allows you to simply set it back if you want to. So let me show you what we can do here in action of these controls. So let's say I'm coming into this application and I want to, I have the iOS version of it here, and I have this text box. So it's just using a default out-of-the-box text box here, but maybe I want to change that. There's a few properties that I could do to modify this application, or maybe I want to actually do some highlighting when I actually tap on this and change the effect of it. So what I can do is come in to my shared code, and I have an effects folder right here, and I have this entry background effect. So that's the first thing that I'm going to do. And I create this effect so I can actually access it from the data binding. So this is called an entry background effect, and it's this routing effect. So it's a little bit of boilerplate code. And we can see inside of here that I'm expecting this myweather.entryBackground effect to be my routing string. And I'll show you where that all comes from. So in one or all of my applications, I can come into, let's say, iOS here, and I have an entry background effect. So what I do first is I export the effect. You see I'm doing a lot of assembly things in here. And I'm saying entry background effect of entry background effect. Inside my entire application, I give it a resolution group name, myweather. Think of it as your company name, or your app name, and this is where all effects are going to live. So this allows effects to be distributed easily. So if I'm creating some, you're creating some, we can go back and forth. So inside of here, it's very, very simple. I have an onDetached and onAttached. On detached, I do nothing. And on attached here, the first thing I do is I set the border style to line. So I give it a line outline so I can modify it. And I also set the background color to this RGB color that I'm storing. Now, I could just stop at that point and say, hey, listen, I get this, this border on it. What I would like to do is actually take it a step further and listen for changes. So I don't have to do this, but I'm going to, where I'm going to listen for element changes. And whenever the focus changes, I'm going to change the background color either from white or to the background color. So toggle it back and forth. and that's it. On and off, and I could even investigate those properties to and from. So with a few lines of code, again, under 20, 30 lines of code with a lot of white space, I can come back into my weather view. I'm just going to go ahead and grab this entry effect. I've gone ahead and brought in my effects namespace. And down here, I can start layering some more XAML. So here, I say effects, entry background effect, and it'll know how to route it automatically. So if I set my iOS project back as my startup and deploy it one more time here, what we're going to see is just in a few lines of code, I'll have a new line entry, and whenever I highlight it or focus it or unfocus it, the background's going to change automatically. There we go. There we go. So now we have this border, and when I tap on it, now it's actually purple color. And when I tap off of it, ideally, I guess it's always focused. It's not going to be the best example of it being unfocused. It should toggle back and forth inside of it. So I can see the weather, and I can change the actual properties that I don't have access to in Xamarin Forms. But I didn't implement it in Android, and I didn't implement it in UWP because I don't have to. It'll automatically be smart enough to know that I didn't implement it on those other actual platforms. But let's say I want to take it even a step further, and I want to do some other things. We have these effects that are very simple. So there is nothing else on this effect at all. But effects can expose additional properties onto the actual control. We call those attached properties. So what I did is I created a shadow effect. And the shadow effect I can add to any label that will actually give it a drop shadow in the code. But what I've done is I've added additional bindable properties. So I'm kind of extending an existing control, but making it so I can add data bindings for color, radius, the distance for the drop shadow. And what I do inside of here is this is what each platform would implement. So if it has a shadow, set has shadow, get color, set color. And what I'm doing here is I'm essentially getting and setting values onto the bindable property. Just like any property, like the text, the background is bindable, we're extending Xamarin Forms. So where there's distances, and I just set up all that stuff inside of here. I also have a few methods like on has shadow change that I can listen to, and I can add or remove different effects. I still have my routing effect called label shadow effect. So I'm going to implement this now on each of the different platforms. So here on iOS, for instance, I have a label shadow, and I'm essentially extending this control. Here is the label shadow. I'm going to set the opacity, the shadow opacity to 1 on the layer. I have a few properties. It's very simple on iOS to essentially set the corner radius, get the shadow, set the offset of the shadow that's on here, and then I additionally listen for property changes. So if I have data binding, I have a slider that's moving back and forth, it'll automatically update it. So I don't have to extend or create my own custom control. I'm just going to add on top of it. The same thing's true over here for Android. I put in a very similar code, but I'm actually using some text views and color distances, and I'm actually setting a shadow layer on top of it, on top of this control. So it's actually very, very simplistic. There's not a lot of code inside of here except to just listen for the different properties. So what's cool is when I come back into my actual XAML, I can grab a little bit different label that's inside of here. Let's say this condition that's right here. We'll go ahead and replace it. I'll set the font size a little bit bigger, though, just so we kind of have it the same. So what we're going to see is that we have these attached properties. So they're custom shadow effect properties that we've extended. And all this code is on the GitHub, so you can grab it and see how this is well done. So here, the label knows that there's this effect, which has shadow, has a radius of 5 and 5. I can even use on platform on top of it for my custom properties, which is awesome. So there's black or red, for instance, over there. So now with just a few changes inside of here, I can take these core changes and then compile it up And I don't have to change ton of XAML. I don't have to override a custom control. I'm still using the base label. I can actually make these generic so they work on anything, but I've done it here just for the label specifically. So here we'll go ahead and launch it one more time. Boom. Come on. Get weather. And then here is our beautiful drop shadow that I put in just a few lines of code, but with those attached properties. So I'm not changing the core functionality. I can easily update and remove them. Cool. Custom renderers, effects, attached properties. Let's talk about what's new and next in the next 10 or so minutes that I have left. There's been tons of features and enhancements that I can't fit into a single hour-long presentation. We have a whole bunch of new stuff that's coming out, including deep linking, embedding, new enhancements to master detail pages, embeddable native controls, and some new blur effects, and a bunch of these actual effects that are built into the platform. So you saw I did some here, but a lot of them are actually built into Xamarin Forms automatically. So one thing that we've done is we've been super aggressive with our bug triage. So we attempt to review every single new issue within 24 hours. And the better the steps, the quicker the resolution, obviously. And we've also done a vast optimization of our performance in terms of startup time and also list view and XAML compilation. What you're seeing on the right-hand side is actually a XAML, compiled XAML in the reddish orange versus non-compiled XAML, the actual inflation time that was done by Matthew Robbins, who does a really cool plugin for Visual Studio for Mac called mFractor. And you can see that using XAML compilation is often 5 times faster in the actual improvement. And we're continuing that with every release, so we're tweaking all the improvements as time goes on. We also have these things called fast renderers and compression. This is something that you won't have to do anything at all, and it's coming out in the current preview release and the next releases of Xamarin Forms. So on top, we have a normal Xamarin Forms application, and we have a grid, we have a stack layout, and some other grids and some other properties inside of it. And what we're seeing on the bottom could be iOS, Android, or Windows 10. And here's just the UWP representation of it that actually gets displayed at the end of the day. So we have 2 panels, some other panels, a content view is a panel, a label renderer, and a text block. So what we're doing here is we just have kind of some unnecessary labels. Like, why do we have a label renderer and a text block? Why do we have additional panels for no good reason? Well, it's just kind of legacy, and we have to shipping it back and forth. So what we've done is we've added automatic layout compression that says what are things that are similar that we can get rid of. So that panel, instead of having multiple panels inside of panels, we compress them down into a single panel, and we handle the layout for you automatically. So right now, instead of all those stack layouts that you have to do, and you're doing stack layout instead of stack layout, we'll automatically compress them and strip out anything that you aren't using automatically. And you won't have to do any work at all. On top of this, though, what we're seeing here is that we could still do better. There's a label renderer and a text block, a button renderer, and a button. So to remove more layers and get more optimization, we're creating these things called fast renderers that will just happen automatically. And we're starting with a few of them that will take this compression and even minimize it down even more into just a few, if not less than what the representation is in Xamarin Forms. This will all come for free and is some of the advanced performance gains that we're doing. In addition to this, we're adding a new layout, which I think everyone's going to love. It's called the Flex layout. Flex layout comes a lot from the web world, but essentially the idea is that a lot of times content is wrapping around over and over again. So the Flex layout is going to be an addition. It's inspired by CSS Flexbox, and it's used for like flowing items, but really good for adaptive layouts when it comes to iPad, big phones, back and forth. So what it'll do is it'll be very similar to your grid, for instance, but you have a Flex layout, and you just add a bunch of stuff into it. And you can set the heights and the widths of it, and automatically the Flex layout will automatically wrap your elements automatically, the heights and the widths and everything for you. So that'll be coming down the pipe. So if you're doing a lot of work with renderers or effects, just know that you'll be wanting to look at this control to really optimize your app. We're coming to new platforms. Forever, we've had Windows support, UWP support, iOS, and Android. But we're not done. We've recently added Samsung Tizen support. Well, the Samsung team did, which runs on 50 million plus Samsung everything, televisions, wearables, mobile, you name it. I'm going to show you the Mac OS support. And also, we're adding WPF and Linux support via GTK. So from your same exact XAML, everything will just work. So this is an application of a media hub that's running on a Tizen television on the right-hand side and a phone on the left-hand side, all from Xamarin Forms, because they have their own .NET runtime that runs on Tizen. And I also have a little tip calculator that the team is using to actually run on an Ubuntu desktop running .NET, since obviously Mono is powered on Linux. And of course, Xamarin Forms can control and lay down native GTK controls, which is really awesome from all the controls that you have. I'm also going to show you really quick what it takes to put your application on another platform. So I'm going to switch over here really quick to my Mac. And I have this in a branch inside that GitHub repo that I did earlier. Let's close out of Skype for Business. I'm going to open up Visual Studio for Mac. And today, inside of the 2.3.5 pre-release, we have Xamarin Mac support. So I took all that same code that we had literally just a few seconds ago in the weather application. I'm just going to go ahead and boot it up really quick here. I've upgraded all of my NuGets to the latest pre-release of Xamarin Forms. And I've added a Xamarin Mac application. So over here, we can see I have Android, iOS. I just removed the UWP one, but it has all of my other helpers that were in here. And I have a Xamarin Mac application. I have some packages that I've added, such as .NET Standard, HTTP, all that stuff, and then all the Xamarin Forms plugins and things like that that I'm using. There's not a lot that I actually have to do inside this application. Inside of the app delegate of the Mac application, I simply inherit from Forms application delegate, very similar to iOS. I go ahead and set the rectangle width and height that I want. And when it's done launching, I just load the Xamarin Forms application. That's it. Inside my main, I simply say that that is my startup delegate. And with that, with literally no other changes to my XAML, so it's not going to be the prettiest Mac application, but it's totally going to be a Mac application, it'll actually start up and run locally on my Mac. So I'll give it a second to compile. And boot up. There it is. There we go. So I can come in. I can see what my weather is. There it is. Using all Xamarin Mac native controls. There's my list view. There's all my items. Everything coming in. And I could, of course, use all my templates and everything like that. And this is kind of the tab structure that they have today. So it's pretty awesome. It's already done, and you can take advantage of it. And you're getting a native Mac application right there. Cool. All right, 3 minutes left. Quick. All right, back to the PC. All right, so let's talk about the last bit and pieces here. Available today is 2.3.5 pre-release of this. This actually retargets Xamarin Forms to a .NET Standard library, 1.1, which is super awesome. We've added additional accessibility support. Fast renderers on Android are available for button, image, and label. XAML-C has been improved even more, and it has over 160 bug fixes and improvements and enhancements. The future, though, that I see is maybe you're not creating a Xamarin Forms application today. Maybe you're still in the Xamarin native world like I am all the time. I go back and forth for my application. But you want to dabble in the world of Xamarin Forms. Forever, it's been one or the other. You couldn't mix and match the worlds easily. You could do it, but it wasn't easy. So what we've done is we've added Xamarin Forms embedding. This is a 3.0 feature that'll come out this fall. And what it does is it allows you to take any Xamarin Forms XAML content page or C# page and embed it into a native Xamarin application with just a few lines of code. So if you think about a Xamarin application with iOS and Android there, you have to build the user interface over and over again. Instead of going all in on Xamarin Forms, we can add just a little bit of Xamarin Forms goodness into it. And we can then extend it into any other type of application because we have another product called the Embeddinator 4000 to embed .NET applications into Java and Swift applications. What's cool about this is it works anywhere, and it works with dependency servicing, messaging center, and we really plan to take it to all sorts of different platforms because we want Xamarin Forms everywhere. So I have one more application that I'm going to show you and switch over to. And what I have is an image search application. And this is going to use Bing image search to essentially load all of my, to go out, I can search for anything. And it's a Xamarin native application. So if I actually come inside of here, we can see that I have a Android and iOS project. I have a full storyboard with a collection view. I have a bunch of resources and layouts. And when I go into my main Android XML, I have a recycler view, and I have items and details. So this is just a Xamarin native application. And what I wanted to do was see how easy it would be to extend this application with Xamarin Forms. So we'll let that spin up here in a second. So I've already structured it in an MVVM way. So I have image results, I have Bing image results, I have an emotion engine to do cognitive services on it, and I already had a view model. So what I wanted to do was extend it with Xamarin Forms. I'm going to see if that's going to spin up or not. We'll just close everything. There we go. I wanted to extend it with Xamarin Forms and say, hey, can I just take a little bit of XAML in this content page and add a details page whenever I navigate and click on an item? So this is where Xamarin Forms embedding comes in. So what I do inside of iOS is whenever I tap on an item, I simply come in right here, and I pull in the Xamarin Forms libraries. I create the XAML details page, and what I do here is I say, Xamarin Forms page, create a UI view controller for me. It'll automatically give me a UI view controller, and then I can use my native apps application to push the view controller. When I come over into my Android application, I have a details page, very similar. The only difference that I do here is that I create my details page and I say, create fragment. So I create one or the other. So what's cool here is that I'm now able to take an existing Xamarin native application, which gives me the benefit of access to every single control, optimizing super fast startup time, and bring in pages of reusable Xamarin Forms logic. So we'll give this a second to spin up here. And that XAML is one XAML then shared across iOS, Android, and Windows that it also supports. So if I search for some monkeys inside of here, for instance, I can go get all my monkeys. Up, 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 up. Come on. Come on, phone. There we go. I assume I have like one bar of anything. Perfect. So I have like a recycler view. I have some images that aren't loading for some reason. But now I can tap on an item, and this will actually go into the Xamarin Forms page. I can actually analyze images, and I can actually get all of this right here from Xamarin Forms. So that's all coming in across the wire, and that's being shared. Obviously with my iOS application. So if I set my startup here, and I set that over to my iPhone, I can set that same thing up on my simulator, and we'll see if it's here. I think I already have it. Image search. There we go. Should be able to tap on this. Do it. Monkeys. Tap on one of them. And it gets navigated across with my super crappy Wi-Fi, but it totally works. And I'm sharing that same exact page and the images automatically for me. So now I can go in and modify the XAML and bring it in. And I really think that's the future of Xamarin Forms and Xamarin Native together. We're making it super easy to combine the worlds. So of course, you can get all of this information from Xamarin.com. I have my slides and my source code there. We have Xamarin University. That's awesome. I super appreciate it if you follow Henry and his advice to grab a green piece of paper and put it in there, because I love it. If you guys have any questions at all, feel free to reach out to me at any time. I would love to talk to you more. And have a great rest of NDC. Thank you.